All right, ladies and gentlemen, so we're going to get started with Chapter 8.1 Notes Day 2. We're going to be adding and subtracting polys. That's what the title is. Goals for today, just reviewing Day 1 stuff. We're looking at degree of polynomials, classifying a poly based on the number of terms, and then adding and subtracting these guys. That's the new thing. So let's zoom in here. First thing is, let's rewrite it. Who thinks they know how 7x cubed minus 4x fifth should be rewritten? What do you got, Ivan? To the fifth? And then what else? Very good. So again, standard form, guys, is the power of x. It's getting smaller and smaller and smaller. So we start with 5 and then go down to 3. Perfect. How many terms do you have and what do you call this thing? This is a binomial. Bi meaning 2, there's 2 terms. So this is a binomial. And then degree, what is its exponent? What do you got? Yep. 5. Man. Perfect. So that thing is in descending order now. It is a binomial with degree 5. Okay. The largest exponent. Very good. I take a look number 2. I got 4a squared minus 3 plus 2a. Cole, you got this one?
4a squared plus 2a minus 3
Trinomial. Tri meaning 3. There's 3 terms. And degree is 2. Eventually we would call that a quadratic trinomial. But we're not there yet. Perfect. Good job, bud. Ivan and Colton. Great job. Any questions for Ivan or Colton for 1 or 2? And moving our way across. Last one, number 3, I've got negative 8x plus 5 plus 2x cubed minus x squared. Who's got this one written in standard form? Noah, you got this one?
Yeah. 2x to the third minus x to x cubed, no, x squared.
Yep.
Minus 8 to the x and plus 5.
There we go. So 2x cubed minus x squared minus 8x plus 5. Boom. How many terms do you guys see there? I'm seeing 4 fingers, right? 4 terms. So this is not a binomial or a trinomial or a monomial. Mono mean 1. This is just the old polynomial. So we have special names for 1, 2, or 3 terms, and after that we just call it the old generic poly. Polynomial means 1 or more terms. Okay. Last but not least, degree. No, you got the degree of this guy?
3.
Yep, the largest exponent is a 3. Okay. And I'm assuming we know we're getting degree from this guy, right? Once you have it in descending order, it makes it pretty easy to come up with the degree. Just look at your first term. And there's its degree. Degree 5. Boom. All right. Any questions, y'all? All right. So goals, learning goals. As students will be able to add and subtract. And let me zoom out just a touch. So students are going to be able to add and subtract polynomials. That's our goal for today. All right. So it takes a look. When we are adding, subtracting polynomials, we're going to be adding and subtracting like terms. Okay, so like terms, what do I mean? First off, the variables are the same. Okay, so in this case, x. So possible like terms are x, 2x, 3x, 4x, 5x, x, negative 2x, negative 3x. If I have an x squared, then like terms would be x squared, 2x squared, 3x squared, negative 4x squared, negative 5x squared, what have you. Okay. If I have an x cubed, well, they're all going to be cubed, x cubes. Bless you. If I have x squared, y cubed, z squared, then all of them have to have the same variables, same exponents. So if I'm adding and subtracting like terms or adding and subtracting polys, they have to be like terms. Same variables, same exponents. Same variables, same exponent. So let's take a look. Example number 1. We want to simplify this guy. I've got 7p squared minus 4p squared. I have the same variable p, and they're both squared. Same exponents. Just combine your like terms. What's 7 minus 4? 3 and p squared. It's that easy, guys. It's what's apple plus apple. I've got 2 apples. Not 2 apples squared. You don't touch the exponent. You just add the numbers in front. Those are called coefficients. I've got 12mn squared minus 13mn. They both have an m and an n squared, so I just take the numbers in front and add and subtract. What is 12 minus 13? Positive or negative? That's a negative. Big number's negative, right? So this is a negative m n squared. Okay. Now some people might do negative 1 m n squared, but it's assuming that you know that if you have a 1 or a negative 1, you do not need to write the 1 in front. Like 1x is just x. It's assumed that you know the number in front. Or negative 1x is negative x. So I would prefer this one, guys. Just negative mn squared. Easy peasy. So I take a look at number 3. I've got x to the 4th minus 3x to the 4th. Just take the numbers in front. What's the number in front of this guy? Just the 1. So take 1 minus 3. What's 1 minus 3, y'all? Negative 2x to the 4th. Okay. Do not touch the exponents. If I have an apple and I add an apple, now I have 2 apples. I do not have 2 apples squared. That would not be, it would be silly, right? So x plus x is 2x. Okay. Don't touch the exponents. So we take a look at the backside. So now we see a polynomial like this. Added or subtracted to another polynomial. Okay. So as I take a look, I got some 9s here, or some y's. I've got a 9y plus a negative 3y. So I'm going to do those in blue and underline those guys. Those are my like terms. So I take a look. What's 9y minus 3y? That gives me 6y. Okay. Now I'm going to use a green color. I'm going to circle my x's. I've got a negative 7x and an 8x. So what's 8x minus 7x, or what's negative 7x plus 8x? How many x's do you have now? Somebody with a hand up. Gail, you got it? 1x, or we just write that as just plus x. If you do plus 1x, it's okay, but we need to start getting used to writing just as x. But that's good, Gail. Good job, bud. How we doing? Last but not least, let me use a triangle here for the a's. I've got 15a minus 8a. How many a's do you see? I've got 15 minus 8. I take those away, and that gives me positive 7a. Okay? Now, can I add 6y plus x? Are those the same? No. One's an x, one's a y. Leave those separate. Same thing with the a. I can't put x plus 7a. Those are unlike. The only thing you could do is to make this perfect standard form is if you have a bunch of variables that are different, in this case x, y, and a, usually we write it in alphabetical order. Okay, so what I would do is I would probably rewrite in alphabetical order. So final answer I'll write as 7a plus x and then plus 6y. So again, a is the first letter in the alphabet, so I'd probably put that guy first. X is the next letter, and then y is after that. So final answer is this guy. All right, any questions? All right, so I take a look. Number 5, see if you can't figure this one out. I've got 3a squared plus 3ab minus b squared, and that's plus the binomial 4ab plus 6b squared. Look at the different terms that we have. We got an a squared, we have an ab term, and we have a b squared term. So put like terms together. So take a second, try number 5. All right, let's take a look at this guy. I've got 3a squared. Do you have another 3a squared anywhere? No, so that guy's just all by himself. Oh, poor guy. He's all by himself. Then I look, I got a 3ab. Circle this guy in green. And I got a positive 4ab there. So go ahead and put those two together. What's 3ab's plus 4ab's? What's 3 plus 4?
7.
Yeah, that'll boy, 7ab's. And then last but not least, in triangle, I got negative b squared and then plus 6b squared. So add them together. What's 6b squared minus a b squared? How many b squareds are left? How many? Yeah. JP says 5b squareds. Okay. Again, the first letter in the alphabet's a, so I got a squared, and then a 7ab, and then a 5b squared. This is in descending order for the power of a. It's getting smaller and smaller. So this thing's all set. So we had some like terms, we had some ab terms, and we had some b squareds, but not an a squared term. So we just leave that guy by himself. Okay, you guys have any questions? Pretty easy, right? Now, it gets a little bit tougher. This one shows me that I'm taking this binomial minus this binomial, okay? So that's why this one's a little trickier, is because I've got this negative. The idea is I'm subtracting both terms from that binomial. I've got to kind of distribute this guy. Okay, so I'm going to rewrite this. I've got 7a minus 10b, but then I'm subtracting 3a, and I'm subtracting 4b, like that. So I'm subtracting both of those terms. If I subtract a positive, it's now negative. If I subtract a negative, that's now positive. Okay, you guys see what I did here? All right. Let's take our 7a minus 3a, add those together. Kyle, what do you get? 4a, boom. And I got negative 10b minus 4b. If you owe me 10 bucks and borrow 4 bucks now, how much money do you owe me? 14 bucks, and you better pay, or I'm going to sick Ivan on you, right? My main man Ivan. He's going to come collect my money. Final answer, I get 4a minus 14b. Final answer. So use that same idea when you do number 7. Use that same idea when you do 7. You are taking one trinomial and subtracting every term of the other trinomial. I like to rewrite it. Positives become negatives and negatives become positives. Right? Flag me down if you need help. Bless you. Bless you.
Thank you.
Guys, I'm seeing people with earbuds in. Let's put that thing away. Those little earbuds are, oh man. Keep those guys away. Hard to concentrate when you got heavy metal in your ear or something.
So I just use that. Just keep the two.
So what I usually do is rewrite these, right? Because it's subtraction. So watch out, there's subtraction in there, y'all. So if there's a minus sign, I always rewrite that second set of parentheses, that second trinomial. So, this is kind of like the distributor property, guys. What's that? Okay. So that's a negative 2y squared. What's a negative times a negative, guys? That's a positive, so that's really positive 4y. And negative times 3 is now negative 3. You're subtracting 3. Okay? So this guy's still 3y squared plus 7y plus 8. But I've changed every sign for that second trinomial. And now it's just combine your like terms, right? These two guys together. What's 3y squared minus 2y squared? What do you get? Rylan, what do you get? 3y squared minus 2y squared. 1y squared or just y squared? Boom. Now I got 7y plus 4y. Lauren, what's 7y plus 4y? 11y. Perfect. Last but not least, I got 8 minus 3. What's 8 minus 3? Taya, what do you get? Plus 5. Perfect. There's nothing else I can do. I can't just put that all together as one because these are separate, unlike terms. One's a y squared, one's a y, and one's what we call a constant that has no y. It's in descending order, so we're all set. All right. So let's do the others two here, other three. Sometimes you might see it underneath each other. Okay, if you have it stacked up like this, it's always nice when the like terms are underneath each other. So either all we got to do is add down. So as I take a look, this thing's ready to go. I have x cubes underneath each other. So Damien, what's 9x cubed plus 2x cubed? What's 9 plus 2? 11. And then just put an x cubed behind it. Perfect. And Tyler, what's 3 minus 5? Negative 2. All done. Boom. It gets tricky though when you see a subtraction there. So I'm a big fan of adding the opposite. So I'll either rewrite this one or I'll just make this a plus, but I'll change that to a negative and I'll change that sign to a negative. Okay, so I add the opposite. I'll distribute the negative sign to all the terms inside. So this one I got 3a cubed minus 2a cubed, so that's a cubed, 3 minus 2. And what's negative 9 minus 1? How much do you guys get there? You owe me $9, borrow a buck, how much do you owe? You owe me $10. Okay? So it's really nice when it's stacked right over each other. And of the basic ones, here we go. I've got 3c squared plus c minus 9. And then that is subtraction of this trinomial, c squared minus 2c plus 1. I'm a big fan of changing that, either rewriting it or just add the opposite. I'll make this a plus. That's now negative. That's now positive 2c. And that's now a negative 1. So I've changed every sign. Positives go to negatives, negatives go to positives. Does that make sense? Yes, no? Thumbs up on that? Thumbs up, thumbs up, thumbs up. Just adding the opposite. All right, here we go. Morgan, 3c squared minus c squared. Boom. Katya, c plus 2c. There you go. And negative 9 minus 1 is again negative 10 again. So final answer. You guys good? All right. Next class you guys will take, most of you will be taking geometry. So as we take a look, a little preview of geometry. Bless you. All right. So as I take a look, number 11. It says draw a picture for each word problem and label your sides and then find the answer. So on number 11, this reads, the perimeter of a trapezoid is 7x squared plus 5x plus 5. First things first, what's a trapezoid? Do you know what a trapezoid is?
Yeah,
Colton?
I know like a rectangle, but
It's like a rectangle. It's got 4 sides.
Easier to like,
Okay. Sure. Colton's drawing it out here.
isn't it like this?
Yes, sir. So I'll draw what Colton was drawing, something like this. This is a generic looking trapezoid, right? It's got 4 sides. 2 of the sides are parallel. All right, we call those the bases. So we say bases are parallel and the other 2 sides are not parallel. If they were, then we'd have a rectangle. Okay, so just random trapezoid. Okay. The other key word there is perimeter. What's the perimeter, guys? So that is a key word that we should know. Perimeter. If I said go to the perimeter of your property and walk around, what would you do? Yeah? Anywhere, like zigzagging and all around? Yeah, so the outline. So perimeter is walking around the whole outside of your property. Perimeter is basically, we're talking about a shape, is adding up all sides of your shape. Okay? So perimeter of a shape is the sum of the sides. Okay? So it says the perimeter of this thing, in this case, is 7x squared plus 5x plus 5. Okay? One side length, I don't know which one it is. I'm just going to call it this guy over here. One side is x squared plus 3x minus 5. Right? It says another side, I don't know which one it is. I'm just going to write it up here, is x squared plus 2x plus 3. And the third side, I don't know which one it is. Maybe it's this long one here, is 2x squared plus 3x plus 6. It says find the expression for the fourth side. They're asking us to find what this guy is. Question mark. So again, I have my perimeter, which is the distance around your object. Okay, the sum of the 4 sides. And they told us 3 of the 4 sides. So who has a suggestion on how we can find out what this guy is? What can we do to find out the length of that 4th side? Yep.
Subtract the total perimeter from with all the like so 7x x squared plus 5x plus 5.
Okay. All right, so if we can, I think what Colton's saying is if we can add up all these numbers, right? If I can add up these like terms and subtract that from this, then I'll find out what's left. Doesn't that make sense? Here's like a basic idea of like using numbers, right? Let's say the perimeter of our object is 40, right? And this guy is, I don't know, 10. And this guy's 12. And this guy's 8. How do I find this guy? Well, I add up the ones that I have, right? And subtract from what's left. Doesn't that make sense? So I can add these guys up. 10 plus 8 is 18, plus 12 is 30. Subtract from 40, that gives me 10 left. Make sense? Well, kind of same idea. Just do algebra. You guys like algebra, right? So let's add these guys up here. What's x squared plus 2x squared? What is that? Add those all up. What's 2 plus 1 plus 1? How many x squareds do you have? 3? 4, right? 1 plus 1 plus 2 is 4. I got 4x squareds. Perfect. All right, let's look at the middle term. 2x plus 3x plus 3x. What's 2 plus 3 plus 3? How much is that? How many x's do you have? JP, you got that one?
How many x's do you have?
Yeah.
you add all of them together?
Yep, what's 3x plus 3x plus 2x?
You have 2 plus 5, 6, or I mean 7, 7 plus 3 is.
What's 3 plus 3?
3 plus 3 is 6.
Plus 2. 6 plus 2.
8.
There you go. Perfect. And then do your constants, the ones that don't have x's. What's 3 plus 6? 9 minus 5. 4. So that's the sum of our 3 sets. Well, this is the sum of all 4. So go ahead and take this and subtract 4x squared plus 8x plus 4. Now, the most common mistake is people just subtract this guy and they don't subtract the whole thing. Right? Does that make sense? So make sure you're subtracting every term. So I'm going to add the opposite like we talked about. I'm going to change every sign. And what's 7x squared minus 4x squared? What do you get there? What's 7x squared minus 4x squared? Griff, what do you get? 7x squared minus 4x squared.
3x squared.
That a boy. What's 5x minus 8x? Andreas. What's 5 minus 8? Negative 5 minus 8. How far is 8 away from 5? There you go. Negative 3x. And then 5 minus 4 we all know is 1. Very good. So for my fourth side, my final answer would be 3x squared minus 3x plus 1. Guys good? Questions? You want to do the last one here? Add a little geometry, a little algebra, a little mixed together, a little synergy. As I take a look. Number 12, it says the length of a rectangle garden. Rectangle. That's the key right there, right? Draw a rectangle. I'm a big fan of drawing what I'm talking about. So I got my rectangle. Length of a rectangle garden is 5 more than 3 times the width. It says the perimeter is 250 feet. So again, my perimeter distance around all the objects is 250. Find the dimensions of your gardens. Now you guys have length and width, right? This guy's length, and we'll call this guy the width. And they say the length of a rectangle garden is 5 more than 3 times the width. Okay? So it's 5 more than 3 times the width. So here's 3 times the width. Which one's more? This one or that one? The length of the garden is 5 more than 3 times the width. The length is, right? By how much? So these are not equal, right? So this is 5 more than this one. So what do I have to do to get this to be equal? I need to add 5 to one side. This guy weighs more, right? Think of a scale. Length is 5 more than 3 times the width. So what do I have to do with 3w to make it equal? Add 5 to it. You guys okay with that? So anytime they compare something, I always set them equal to each other and be like, I know they're not equal. How do I make it equal? So they're comparing length with 3 times the width, and they're saying those are not equal. Length is 5 more than 3 times the width. We'll make it equal by adding 5 over to 3w. All right, so this guy here is 3w plus 5. That means this guy is the same. That's what a rectangle is. Opposite sides are congruent or equal. And that guy's w. So far, so good? All right, what does perimeter mean? What do I do? Walk around, and what should you do as you're walking around? What do we do with all these sides?
Add them up.
Add them up, right? All right. So let's take all these sides and add them up. Add up your like terms, add up your W's. What's 3W plus 3W plus W plus W? How many W's do you have? What's 3 plus 3?
Oh, 6.
6 plus another W plus another W. I got 8 W's. Make sense? And 5 plus 5 is 10. That's my perimeter. As I walk around and add this up, I got 8W, and that's equal to 250. Right? You guys know 50? 50 Cent? Right? Dr. Dre? Yeah, Tupac. I know all those guys. All right. Come on, that's funny. Snoop. Snoop-a-loop. All right. Solve this thing. A little algebra now. How do we solve for W? What do we got to do with this 10? Colton? There you go. Move it on over. Get this W by itself. 250 minus 10, that's 240. And now the last step, go ahead and divide by 8. Divide by 8, right? That's 8 times W, the opposite of times. Well, division. And what is 240 divided by 8, y'all? What do you get? Okay, that's 30 feet, right? So we get W is 30 feet, and they want the dimensions. That means they want both of them, right? They want the width, they want the length. Go ahead and plug that in. 3 times 30 plus 5. What's 3 times 30? What is that, 90? 90 plus 5? What is that, 95? So my length, my width is 95 by 30. And we're talking about feet here. Great question. Okay. Ladies and gentlemen, that is it for chapter 8-1, day 2.